Here we go, folks, with example number 8 on inequalities. And I can't say this enough times. I'm a huge, passionate believer in the approach that will work for every kind of inequality instead of learning different ways to do it, depending upon the type, linear, quadratic, higher degree, absolute value. Do the equation first, all right? So we'll pull that over here. And this would be a higher degree equation because of those higher powers, fifth power, fourth power, etc. So you would hopefully flash back to higher degree equations. And, you know, this was, as I recall, assignment number 12. All right? So I'll put that up here. But the idea would be, and I just went away from it. That was smart. Let me get that back up there. There we go. All right. So because of the multiple x's throughout the equation, let's get all the terms on one side, make it equal 0. See, the nice thing about this is that at the end of a chapter, which this would be, and did I mention you're not going to have tests, all right? But anyway, this is a good review of all the different equations. So we get it in standard form, and then we factor it if at all possible. You will note here that x cubed can be factored out. So we have x squared minus 6x plus 9 in the parentheses. And then I should have tested my markers before I started this question. Hopefully one of these is working well. And then this will factor, which is assignment 5, by the way. That'll factor as x minus 3 times x minus 3. So we have 3 factors here. And if we set them each equal to 0, this would lead to 0, right? 0 cubed. What do you put in for x to make that 0? 3. What do you put in to make that 0? 3. 3 minus 3, okay. So 0 and 3. Same number twice. We don't have to put it on there twice. So 0 and 3. That's old stuff for us. So we come back, we look for division by 0. There's no fractions. No worries. So our test line for x will have the numbers 0 and 3. Right? Those are the two critical numbers that we've got. I don't know how many you're going to get. I could give you a question where there's 4 of them. I didn't, but I could. All right, now, equal to, which is where those two came from, equal, is not in this question. So, these numbers will not satisfy that question, because equal to is not a relationship that's in the question. It makes sense to me to put an open circle there to indicate, okay, those aren't going to work. Time to test some numbers. I would recommend testing -1. It lives over here. All right, so -1 to the 5th power, since that's an odd power, would be -1. -1 to the 3rd power, since that's an odd power, would be -1. And -1 times +9 would be -9. Mental arithmetic. I'm on thin ice here. I get it. I'm trying to get up as much of this material as I can. -1 to the 4th power is 1, because that's even. And that 1 times 6 would be 6. So this ends up being -10. This ends up being 6. And -10 is less than 6. And wah, wah, this question wanted greater than. Didn't work. Let's pick a number here between 0 and 3, about 1. Put it in for x. 1 to the 5th power is 1. 1 cubed is 1 times +9, that'd be +9. And 1 to the 4th power is 1 times 6 is 6. And again, I wait until I'm done doing all the math, so I put a question mark there temporarily. But we have a 10 here, we have a 6 here. 10's greater than 6. And why am I excited? Because I noticed the greater than is the symbol in the question. Yay! And so, look at that. These numbers here, between 0 and 3, I'm coloring it in, all right? Yeah, greater, yay, greater! All right, if it matches the question, it worked. That's the point. All right, let's pick a number out here. I'm going to recommend 10. Sorry, these markers, I should have checked them before I got going. 10 to the 5th power. Oh my gosh. 10, 100,000, 10,000, 100,000. 10 to the 5th power is 100,000. Ooh, that's a good marker. Plus 10 cubed. You're welcome. That's 1,000 times 9. That'd be 9,000. And then 10 to the 4th power. 10 times 10 times 10 times 10. That is 10, 100,000. That's 10,000 times 6. 60,000. You get really good at crunching these numbers. I should probably be writing it all the way out, but it's mechanical arithmetic, and we're in college, and I'm a snob, and all that, okay? So, notice that the left-hand side produced a number that's greater than the right-hand side, and I get excited because greater is in the question. And so, that interval also worked. So I'm here to tell you that, people who are into memorizing patterns, which is a different way you could teach this, unfortunately, some of those patterns, people will say, they alternate. Didn't happen here, did it? There's exceptions to those patterns that other people would have you memorize. And guess what? Mr. Soda Pop often will give you the questions where the exceptions come into play, where the patterns don't always hold up. You're welcome. Look, if you just put the numbers in and crunch it and do arithmetic, you'll be fine. So what do we have here? 0 to 3, exclude, all right? And then we hop over the 3, and then we got this totally other separate piece from 3 to infinity. So we got two totally separate pieces. We can't say 0 to infinity because that would include 3. So we have to break it up into 0 to 3, 3 to infinity. And I'll remind you again that we leave out those endpoints with parentheses symbolically. So there's that example. And I'll be the first to tell you that there was another part to this question, but in the interest of time, we're going to leave it at that. That should be sufficient to help you do well with this. Awesome.